So, it's a yesterday's challenging problem of the day. Just have a look how to solve. It's a multi-conceptual problem. It involves with the concepts of limit as well as concept of quadratic. So you just read out the problem once. Let alpha of a and beta of a be the roots of the equation. Cube root of 1 plus a minus 1 x square plus square root of 1 plus a minus 1 into x plus sixth root of 1 plus a minus 1 is equals to 0 for a greater than minus 1. Then the question is about finding limit a tends to 0 plus alpha of a as well limit a tends to 0 plus beta of a. Right. See, the problem is it is related to the concept of limit as well as concept of quadratic. As I said, you just look at this problem. There are different ways to answer this particular question, and this is a question from advanced 2012 actually. See, in my way, how I do is you just substitute this a plus 1 as some t power 6. Why? Because here I have cube root, here I have square root, here I have sixth root. To balance this, how I do is I will substitute with t power 6. That's one way. See, just have a look. Take 1 plus a is equals to t power 6. We need to take what? 1 plus a is equals to t power 6. If we replace 1 plus a with t power 6, how the problem will change? That's the thing. That's what you need to identify. Just have a look. I am erasing this for the space concern. Right. If 1 plus a is t power 6, then the question will become cube root of 1 plus a, cube root of t power 6, which is nothing but t square minus 1 into x square, plus square root of 1 plus a, that means square root of t power 6, which is nothing but t cube minus 1 into x, plus sixth root of 1 plus a. Sixth root of 1 plus a is directly t minus 1 is equals to 0. See, if you replace 1 plus a with t power 6, the question will become with a quadratic in terms of x whose coefficients are in terms of t. Now, we need to find out the roots of this, because alpha and beta are the roots of this. We need to find the roots of this as a tending to 0 plus. See, as a tending to 0 plus, it is very clear that 1 plus a tends to what? 1, and so t power 6 tends to 1. That in turn indicates that t is also tending to 1. Just have a look. T is also tending to 1. Since t is tending to 1, that in turn represents that the value of t is nearer to 1, but it is not equals to 1. Since it is not equals to 1, it is very clear that t minus 1 is a non-zero value. So you just divide everything with t minus 1 now. If you divide everything with t minus 1, what will happen? This is t square minus 1. So t square minus 1 is t minus 1 into t plus 1. Okay. You need to divide this completely with t minus 1. Then it becomes t square minus 1 and it is t minus 1. You will get it as t plus 1 into x plus t cube minus 1 by t minus 1. See, then it is t square plus t plus 1 into x plus 1 is equals to 0. If you divide this completely with t minus 1, this is the thing. And now, since t is tending to 1, now you just replace t with 1. Since t is tending to 1, t minus 1 is a non-zero value. So we have a chance to divide completely with a non-zero value t minus 1. And then now t tends to 1, replace t with 1. See, this is x square, okay? If you replace t with 1, it becomes like 2x square plus 3x plus 1 is equals to 0. Now I think it is very easy for you all to find the roots of this particular quadratic. What it is? Tx square plus 3x plus 1 is equals to 0, whose roots are nothing but, okay, what are the roots? Minus 1 by 2 and minus 1. Just check it. since the roots of this quadratic minus 1 by 2 and minus 1, that in turn represents that alpha A is minus 1 by 2, beta A is minus 1, as A is tending to 0 plus. So because while to find these roots minus 1 by 2 and minus 1, we internally used this particular limit concept. Okay, in a symbolic notation, I am not mentioning here as limit A tends to 0 plus alpha of A, limit A tends to 0 plus beta of A. But internally in solving the problem, already we utilized the concept of limit. Okay. See, this is a multi-conceptual problem with a combination of limits and quadratic. And as I mentioned, this is an advanced 2012 problem. Okay. So once again, just look this. Okay, we need to find out the roots of these two, and they are alpha A and beta of A as A tending to 0 plus. First of all, I am just replacing 1 plus A with t power 6, and I converted complete problem as a quadratic in terms of x whose coefficients are in terms of t. As A is tending to 0 plus, t is tending to 1, so t minus 1 is a non-zero thing. Divide everything with that non-zero thing, so you have this particular equation. As t is tending to 1, you left with 2x square plus 3x plus 1 is equals to 0, whose roots are minus 1 by 2 and minus 1. So at the end, the roots of this are minus 1 by 2 and minus 1. How you arrived at this point? By using this limit A tends to 0 plus, and so as A tending to 0 plus, alpha of A and beta of A are minus 1 by 2 and minus 1. That's the problem. Okay, that's it. Okay, have a look.